In this lesson, we are going to discuss circles. So first we have the standard form of a circle, which is x minus h quantity squared plus y minus k quantity squared equals r squared. A circle is a set of points in the xy plane that are a fixed distance r from a fixed point hk. R is the radius, and that fixed point that's the center is represented by HK. So that's the center of the circle. Just be cautious. If we're given the standard form, we can find the center by looking here. But when we write down the ordered pair, notice our formula is minus H and minus K, and our ordered pair is positive. So if sometimes we might have a plus some number, that means that ordered pair would be negative. So think opposite in that sense. Some special cases here, when the center is 0, 0, we can just use the equation x squared plus y squared equals r squared, because x minus 0 is just x, y minus 0 is just y. So that is commonly used. And then we also have what's called the unit circle. The unit circle is when the center is 0, 0, and the radius is 1. So our standard form for that is x squared plus y squared equals 1. So here in this example, we are going to write the standard form of the equation of the circle with radius 5 and center negative 3, 6. So r is 5. This is our HK. So we're going to have x minus negative 3 quantity squared plus y minus 6 quantity squared equals 5 squared. So to clean that up, we have x plus 3 quantity squared plus y minus 6 quantity squared equals 25. And that is your standard form, where we have our center HK in there and our radius is squared. And next here, we're asked to graph the equation as shown there. In order to graph an equation, we need to know what the center and the radius is. So since this is written in standard form, we can easily gather that information. So the center, remember this is where I say think opposite, is negative 3 for the x value, positive 2 for the y value. And then our radius, remember this part of the equation is the radius squared, so we need to take the square root of that, so the square root of 16 is 4. So when you graph a circle, you plot your center point, so negative 3, 2. And then just use your radius of 4 and go 4 units in each direction. And then from there, you just try your best to connect those 4 points you just drew. Ooh, that was not good. And you have your circle. All right, you guys are gonna be doing it with the computer program anyways, so it's the best I got. Okay, moving on. How we can find intercepts with circles is the same way we did previously. To find x-intercepts, we're going to plug in 0 for the y value, and to find y-intercepts, we're going to plug in 0 for the x value. So here, if we're finding the we're finding the x-intercepts, plug in 0 for y. So x plus 3 quantity squared plus y minus 2 quantity squared, except for we're plugging in 0 for y, equals 16. So we're going to leave this as x plus 3 quantity squared plus, this is going to be negative 2 squared equals 16. X plus 3 quantity squared plus 4 equals 16. We're going to subtract 4 from both sides. So that equals 12. Now that we've isolated what's being squared, we take the square root of both sides. So x plus 3 equals plus or minus the square root of 12. I'm going to go ahead and break down the square root of 12 here off to the side. The largest perfect square that goes into 12 is 4. It's 4 times 3. Square root of 4 is 2. So we now have, let's see here, go right here. X plus 3 equals plus or minus 2 square root of 3. And then we subtract 3 from both sides. So x equals negative 3 plus or minus 2 square root of 3. And that's kind of the correct form to write it in there. Let your radical come last. And we could find a decimal form if we want, but sometimes you're asked for the exact, so we'll leave it at that. We're going to do the same thing for the y-intercept. But we're going to plug in 0 for x. So 0 plus 3 quantity squared plus y minus 2 quantity squared equals 16. So 0 plus 3 is 3. 3 squared is 9. 9 plus y minus 2 quantity squared equals 16. Subtracting 9 from both sides, we get y minus 2 quantity squared equals 7. Here we take the square root of both sides. So y minus 2 equals plus or minus the square root of 7. And then we add 2. So y equals 2 plus or minus the square root of 7. Those would be our two y-intercepts. And last here we have general form of a circle. The general form of a circle is x squared plus y squared plus ax plus by plus c equals 0. So it's set equal to 0. Everything's on the left-hand side. And to get that, you're really just taking your standard form and you FOIL and subtract your constant over. So if an equation is in general form like this, then we're going to use the method of completing the square to put it into standard form, so that way we can get the center and the radius from it so that we're able to graph it. So it's probably been a while since you've completed the square here, but I'm going to group the x terms together and the y terms together and set us up. So x squared plus 4x plus blank plus y squared minus 6y plus blank equals, now I'm moving this 12 over and I'm doing that by subtracting, so we got negative 12, and I have plus blank because whatever we add to the left side of the equation, to keep it balanced, we have to add it to the right side of the equation. And then right below it, we're going to have our factored form set up. So the purpose of completing the square is to get factored form here. Okay, so what we do here to complete the square, we take half of the x term, so half of positive 4 is positive 2. And then to get our perfect trinomial, we take that number and square it. So 2 squared is 4. I added 4 on the left, so I need to add 4 on the right. Half of negative 6 is negative 3. Negative 3 squared is positive 9. I need to add that to the right-hand side. So now I have 1 on the right-hand side. So to clean that up, we have x plus 2 quantity squared plus y minus 3 quantity squared equals 1, where our center is at negative 2, 3, and our radius is the square root of 1, which is 1. So you can go ahead and plot negative 2, 3. And your center is 1, so you only go 1 unit in each direction. And connect those. And there you have your graph of a circle of that equation, starting with the general form.